My name is Bryan, and I work for IMIT. I'm actually a partner. And what we do is we actually help startups and small businesses, a few corporates that we like, go digital and really capitalize on new technologies, new businesses, new ideas, and really drive home the dollar. Like, I'll be the first person to admit, most of the time it's about the dollar. Today what I wanted to cover is actually something that's become quite a big facet of our business over the past year, which is actually serverless technologies. So what we found with a lot of our clients, actually 100% of our clients, is that by moving to a serverless platform, they can actually achieve benefits across the scale. So if anybody's ever seen that triangle around cost, quality, and time, where you have to trade off one for the other two, serverless promises to actually kind of decrease that size of that triangle, where you kind of get the benefit of the same time to market, lower costs, and the quality stays the same, if not getting better, which sounds like a little bit of a conundrum, but hopefully over the course of the next 30 minutes, you can kind of see maybe how it works, how you can incorporate it into your own work. And I encourage all of you, if you have time after this, to go spin up a server and actually try using a serverless function. It's actually pretty easy, and you'd be amazed at the results. So, quick show of hands: how many people have actually used serverless before? Awesome sauce, right? How many of you guys have deployed serverless in a production environment? Yeah, it's actually quite a bit, considering the youth of the age of serverless. So, for those of you who haven't been exposed to serverless or haven't really done too much in serverless, I'll just give you a quick Cole's Note version. I mean, everyone here is a coder, so you know. The idea of serverless is that we don't really give a shit about where our code runs. It just runs in a server somewhere. So with this example, we have a person sending a message to a chatbot through Slack. Everyone here loves Slack. Slack then sends a message to a serverless control somewhere, probably in AWS or Google. It pulls the code sitting somewhere that we've deployed, takes it into a ephemeral container. The container runs somewhere on the cloud. We, again, really don't give a shit. It calculates the response to the chatbot, sends it back to Slack, and then the user sees a response. Magical, right? So in a nutshell, that's pretty much serverless. Pretty simple.
Okay, but this is stateless.
This is stateless, 100%. So serverless is, I'm sure a lot of you, probably all of you, would have heard about microservices architecture, right? It's really where a lot of the world is moving to, so that all of us coders can have sanity and sleep at night. I mean, my hair is growing gray, but that's for different reasons. So microservices architecture is normally coupled together with things like Docker. So when you introduce serverless into the mix, really it's not a competition to microservices, but rather an interpretation of it. So if microservices is a logical way of classifying the architecture, where you take individual component parts of an application, spread it across different servers, you still get a fully functioning app. It just runs across different pieces of metal. In a single tenant container service, at the top, you can see where we have two examples of Zara and Gap running in AWS Ireland. Each of their services, for example, there's ad hoc inventory, the POS control node that connects to the stores, all of that runs within their own Kubernetes cluster. And that deploys to various Dockers, depending on how fault tolerant it needs to be, what the load is, it floats around. But the key important thing you need to note is that the servers themselves are always owned by that company. So Zara owns their own servers. I mean, they're virtual servers, but they own them. Same thing from a Gap standpoint, they own their own virtual servers, and all their apps are deployed to that. Never at any point do Zara's code ever run on Gap-owned servers. And that's at the OS level. In a serverless system, however, really each company only owns their own code. That's it. The cloud provider, in this case AWS, actually owns the infrastructure, the metal, and the OS layer, so that the little pieces of code that are owned by Zara and Gap, those are actually running on a shared environment all across the board. And they're popping in and out of existence whenever they're needed. So suppose somebody makes a POS transaction at Zara, the POS connection pops up, processes the request, sends it off to the inventory management system, and then disappears, pops out of existence again, right? So, everyone with me so far? So now, from a serverless standpoint, I'm sure all of you who haven't already used serverless can kind of see the different potentials coming out, right? So this is just a very short list of what we can do. There's an extensive list that really your imagination can take you anywhere, right? So right off the top of the bat is offloading calculations, right? So in Hong Kong, being a financial services industry, if you can offload all your calculations into a kind of shared environment, and as long as it's segregated, awesome. You're basically printing money at that point. So things like asset valuations, the big data processing stuff, that's really going to earn you big bucks. Scheduled tasks is one that most people don't think about, but is actually a big component of enterprise workloads, where you have to process, like for example, Zara and Gap, they have to do a massive nightly job to reconcile all the inventory from all the stores across the world. And then from that, they use that to actually drive production of new clothing and new apparel from their supply chain. So scheduled tasks is very important. Serverless deployments can actually help you a lot with that. So you don't have to really invest and use very large scale crons or scheduled task managers. And it's quite a cost-effective solution. Responding to HTTP requests and webhooks, which is really what we're talking about, is API servers, web servers, chatbots, like in the original example. This is where a lot of us working in startups really love playing around with serverless, because it allows us to deploy all these common assets that if I'm an enterprise and I have millions of dollars, yeah, I can throw money and buy a couple nice fancy hardware, rent some space in a data center, and throw some stuff. Startups being poor, serverless presents a nice option for us. And the other aspect that really is awesome, it's more on AWS, but the other guys that come joining in on the train, is actually being able to offer different languages. So everyone always starts off with Node.js and offering it because it's easy to attach code to it, so deploying a serverless environment really makes sense. But AWS is really leading the charge as far as adding new languages. Microsoft is trying very hard, so they've got things like PHP coming in there. There are even some languages I've actually never heard of, but they're all sitting in experimental, which apparently their disclaimer says that we may or may not offer this in general availability. We may kill this feature in the next year or two. So if any of you are working with any exotic languages and you notice that in the Azure Functions environment, definitely pop a note over to Microsoft and let them know that that's actually something you're interested in, because Microsoft needs customer feedback to know what to spend money in. They're happy to spend money, but they just need a use case, right? And startups and devs are really the only source for that information. So I've talked about all the wonderful stuff about serverless, but let me talk about the shitty parts of it. So the biggest one, which I always get nipped in the ass with, is the limited slug size. So I don't know if any of you have ever worked with legacy applications, especially in banking. This shit is older than, well, really I am. And it just gathers dirt. It's like a snowball going down a hill. As code gets older, people just keep on tacking on code to the point when code is 35 years old, it's really larger than a camera can even hold. So serverless, its promise of being able to pop in and out of existence and run wherever is limited by how large the code base can be. So really it kind of encourages you to pursue that microservices route and say, hey, I only want to implement a specific feature of my app, or run a specific calculation and run one specific connection, and then that's what you deploy in that one serverless function. You can have thousands of serverless functions floating around in a nice big soup, but each individual one is limited from a size standpoint, right? And obviously, as soon as you include libraries and dependencies, you can imagine that code base really inflates. The second one, which is one of those nuances, but something you guys should definitely think about if you're thinking about going towards serverless world, is really around the limitations from a RAM CPU standpoint. Each vendor has their own kind of interpretation of how they want to scale this. AWS is really auto-scaling, so it's really purely around RAM. You say how much memory your app thinks it needs, and then they'll allocate a proportional amount of CPU. So we actually had a client where they had a very small memory footprint. I think it was using almost like 50 megs, but because they had heavy horsepower that required to churn data, we actually had to ramp up to the maximum amount to actually push stuff through. That's actually a typo. It's actually only 1.5 gigs for AWS. The other one, which if anybody is Node developers, this one will probably piss you off, is actually, especially in Node, they actually use N-1 LTS. So if we're using version 8 right now, most of the providers are running version 4, which means you don't get all the fancy shit like async, you don't get, oh my god, the list is just immense. It's really annoying. But thankfully we have things like transpiling, so we can transpile down to version 6 and roughly maintain our sanity. Execution time needs no explanation. You guys know what that is. But the last one, which is really the big one, which is the expense. Now, there's lots of debate around what the trade-off and break-even point for serverless environments is compared to traditional bare metal servers or virtual servers. And you'll see some comparisons on the internet floating around saying, hey, if you have a website that gets 10,000 hits a day, you're still better off going with a serverless implementation than renting a server because it's going to be cheaper for whatever reasons, right? But really, when it comes to cost, it's very nuanced. It's how highly available do you want it to be? What is the search capacity? Like, am I going to have 10,000 people show up in 1 second, or is it going to be spread over an entire day, right? That kind of affects how big a server you provision. In a serverless environment, you don't give a fuck about that, right? It's, here's my code, it runs, cool beans, right? If 10,000 people show up in 1 second, the vendor will actually take care of that, spin up as many containers, and you're good to go, right? So for those of you who've tried playing around with serverless and then started yelling at it, something you should definitely try out is a serverless project. It's actually the serverless framework. So what it allows you to do is actually take a vendor agnostic approach to serverless and say, I don't care where this is really running. It can run in AWS, it can run in Cloud Functions, Azure, it doesn't really matter. We actually use this on our own startup as well, where if at any point Google pisses us off too much, we can easily switch to AWS within the span of about 4 hours. We just changed the Google to the AWS moniker in serverless. We have to configure one thing for API gateway because Google gives you REST APIs for free. And we're off to the races. That's it. We just redeploy, and it's living on a new, different vendor. So it's one of those things where if you haven't already wrapped your project at using a serverless framework, definitely investigate it. It'll help you stay vendor agnostic. There's a beautiful plugin architecture which allows you, for example, transpiling. If you love LTS Carbon in Node.js, then you can easily continue working in that. Everything's hunky-dory. So the real-world use cases, if we go back to it for a second, and just term it with one single feature, which is that we're always available and pretty much infinitely scalable service. Then serverless really shows its beauty, right? And I listed 4 examples of where we've noticed it personally and where we've actually implemented this service before and actually gotten some tangible benefits. All of these have characteristics where we have no idea what the server load is going to be. The code base is relatively small. It's either accessed through a web event, like an HTTP request from a browser or an API, or in the case of data processing, it's off a schedule event, right? So we need to do a batch process every hour, or somebody uploads an image, we want to do some resizing for thumbnails. This shit helps immensely. So here's the juicy part. So we don't normally do this, but for you guys special, we are actually going to show you exactly what we did for 2 of our clients. So the first one is where we actually took for startup a little bit cash strapped. We showed them how to actually go 100% serverless. So out-of-pocket expenses from an infrastructure standpoint was, well, it was 0, but it's technically 1 cent because AWS and Google don't let you charge 0 cents. So they had to charge like a token 1 cent, which was ridiculous. And then the second one is actually a financial services firm. So they have existing infrastructure, but I'm going to show you actually how we moved them over to use serverless while still retaining a lot of their staff, and they actually were able to use it. Which is actually very interesting for a lot of people here who are from large companies and worried about how to really implement serverless. We'll take care of that. So the first one is 100% serverless startup. So how many out of you work in a startup environment that hasn't received funding yet? Oh man, Hong Kong's funding scene is improving. Send some money my way. So in this case, this is really at your MVP stage, and you're looking to say, well, let's just throw up our web app, throw a backend, do some data processing. Really doesn't matter what kind of service you are. This is for one of our clients where they actually do a lot of infrastructure management. So it interfaces with a lot of core apps in their client's domain. They connect it up. So their typical deployment structure was like, okay, let's set up a web server, throw web servers on some virtual servers. We have a front end that deploys some React stuff. Hunky-dory, everything's happy, we're good to go, right? And then we said, you know what? You don't have to pay that much. You can actually go serverless. You're earlier in the game. If you do it now, you'll actually reap the benefits once you do really scale up to those hundreds of thousands, millions of customers. Right, so at a basic level, the architecture looks roughly like this, where you have our front end on UI. We made a strategic decision because of the way their team was organized and actually put React as a single page app living in Google Cloud Storage. As you can totally deliver the React app out of an Express backend if you have a smaller team, if you're comfortable doing that way. It's just that we noticed that if you actually deliver React or any single page app out of the static storage, you actually decrease the execution time of a serverless function as well as the bandwidth used by serverless. And those are 2 wonderful cost-saving measures that can usually save you somewhere between 20 to 70%, depending on how large your front-end app is versus the back-end server requests. So we had React set up. We had wonderful front end, looked nice and pretty and sexy. The back end became a simple REST API that interacted with React and coordinated all the data coming in and out of the system. And then to really put the cherry on the top, we said, okay, so screw it, do away with that SQL database. We actually went down the path of Cloud Data Store. So Cloud Data Store, if nobody has had a chance to use it, it's a little bit like AWS's DynamoDB, it's a NoSQL storage, just like Mongo. However, the pricing structure is actually quite different. So if anybody's had a chance to deal with AWS DynamoDB and gotten super pissed off by the reserve capacity and getting owned by Surge where, oh, I need to do 10,000 requests in a second because I've gotten whatever. We've hit it on Hacker News or something. And then they've seen basically rejections coming back from DynamoDB saying, oh, you only reserved 15 read units and you're trying to request 500, so bugger off, right? Cloud Data Store doesn't have that problem. It actually is very nice and very civilized that way. So from a startup standpoint, if you expect you may get surge behavior, Cloud Data Store works wonderfully well. And of course, we had supporting services. Auth0 is my favorite from an access management standpoint, and you can wire in any standard logging system to pipe logs from your serverless function into a standard logging. So from an ops standpoint, it works exactly the same way. All the logs come into a central place. They look exactly like normal server logs, with the one exception is there's a serverless execution ID, which allows you to backtrack it to the original execution container and kind of diagnose if something goes really funky. But if anybody is already living in a microservices world, you probably don't deal with that too often. So, now the money slide. So when we looked at this and we said, okay, you have potential, we didn't actually fully understand how much money you could save till we actually put it in, and then we started laughing our heads off. So this, we had the specs at the top where it was around 5,000 users, 200 users concurrently, and they're accessing so many times a day, and they're accessing analytics. That was stuff that we got from the client, and they said, okay, cool. So we kind of mocked stuff together and said, all right, you could have this one server-based deployment. So this is, if anybody's lived in a Google Cloud world, you'll recognize the Google Server instances. They're a little bit wonky, but it's essentially it's a single CPU. It's a dual CPU with 7 gigs of RAM. So you load that thing up. You're basically looking at about $97 per month for running 2. Obviously, you need to be highly available if you're any serious production loads with a load balancer in front, right? So when we did the initial cost comparisons for saying, here's a trade-off kind of thing, we came out with that $35. So this slide originally had a $35 number in it. So I actually took a look at them this morning, and the number for the 10% load is actually what we saw, where they had already done some PR and stuff, so they had some traffic, but they never saw more than 10% of their forecasted load, right? And it turned, I am assuming it has something to do with how many pages they expect users to visit. For most back-end services, all of you developers know that things like New Relic, you basically turn it on, you check it only when shit goes down or bad stuff happens. That's basically their situation, where there was lots of users when they signed up, so they had built this original forecast, because obviously when you first get a new tool or a new toy, you want to kind of play with all the little fidgets and stuff. So they're like, okay, fine, people are totally using it. But as things stabilize, people are like, okay, fine, you know what? This is on, it's capturing data, I don't really need it anymore. They didn't really access the analytics that much. They didn't access any of the logs. The front end stuff was really accessed every now and then. So the load dropped down to 10%. So in our worst case scenario, we were seeing around 300%, so 3 times savings. And then based off today's number, we're pretty much looking at 100x savings. So, I could, that is actually way cheaper than a cup of coffee. I'm remembering how expensive coffee is in Hong Kong. So if you're a startup and you want to deploy now, this is definitely something you consider. If you're really looking at a web server and a front end, totally workable. If you surge, the thing runs beautifully. It does take a little bit of finagling the first time around, just getting around the whole idea that my code doesn't really exist anywhere till it runs. And then, depending on what environment you are, you have a little bit of hot loading issue. Yeah, what?
That 256 megabyte is the memory size, right?
The
256 megabyte.
256. Yeah, that's the because they're running Google Cloud. So Google Cloud has, unlike Amazon, has 2 levers you can pull. You can pull the memory lever and the CPU lever.
I guess they have some sort of database. What is the cost of their?
Yeah. So all services, whether they're AWS, Azure, or Google, they all price their stuff in usually gigabytes per second if it's memory, or gigahertz per second if it's CPU. So Google is the same way. So really that cost per unit is actually an aggregation of those 2 measures. So so that little footnote down there, that's, sorry, not the footnote, the little bit about 256 megs and the 400 megahertz, that's actually the slug, how we configured the serverless slug to run. We found those things tend to work for Node.js servers quite well. You get a good cost performance ratio. We didn't really notice any delays around latency. So you could totally, if you wanted to be a hog, ramp that thing up. You can go up to about 2.4-ish gigahertz, which is some serious horsepower for an execution. Obviously, if any of you have dealt with web servers, you don't need anywhere near that horsepower, because you have to remember, serverless executes a single request, right? So on a normal web server, you totally need the big horsepower because you're handling 100 requests simultaneously. if you were to cut that spec up by 100, that's really how much you need for a single request, right? So you can imagine that's actually quite small. So we'll send these slides out later on. So if any of you want to actually try doing this at home, or you want to get access to a lot more sexier stuff, we'll send them out or figure it out later. So here's the really sexy one. So if anybody's working in financial services, or you have an existing company that doesn't use serverless, or you're kind of questioning how to use serverless to get access to these cost savings and scalability measures, because they really make an employee look awesome. This is our fintech company that's actually a client. So they have an existing proprietary algo that does portfolio valuations. So very big in Hong Kong. It values all the assets based off data from all the various banks for various asset pricings and things like that. The banks as well use them. So you have a lot of API access from their front end, usually coming from Bloomberg or a built-in app, things like that. As well as they have web analytics for the smaller hedge funds and stuff that don't really have custom interfaces. So the analytics stuff is essentially just a Vue.js front end, but it interacts with the exact same PHP backend. So it's actually running Laravel Spark if anybody's used it before. So, I mean, this is pretty much traditional for anybody that's worked in financial services. Yeah, everyone's sounding like, yeah, totally sure. Yeah. Here's the shitty part about this architecture. Low throughput. So if anybody has done financial modeling before knows exactly what I'm talking about. This is perhaps the worst, and if anybody's ever dealt with PhDs before, they think this is awesome. Like, oh, I can run 1 calculation a second. It's great. If you can run 4, it's even better, right? Because what they're talking about is like massive, complex Monte Carlo simulations and things like that, right? So for them, they could, if we use 2 servers, they could only run 4 calculations a second, right? One per core, and that's what we saw. So as you can imagine, if you scaled up, which is 0.3, which is what we noticed and why they originally came to us, was that before and after the morning meeting, so if anybody's worked in financial services, you know about this wonderful 7:30 a.m. morning meeting where everyone gets together and talks about what happened last trade day, what's the plan for next trade day. All the little flunky analysts that work around them, the Oompa Loompas I call them, they usually come in a little bit earlier. They have to re-skim on the news, usually kickstart a lot of financial analytics, put together reports, and then all the traders sit down at 7:30 with their very expensive coffee and talk about all the analytics and how much money they're going to make over the next day. So what they found is that all the Oompa Loompas do a whole bunch of calculations just before that meeting because they're procrastinators. And then something happens in the meeting. And then they quickly go back and redo the calculations because something changed, right? Usually like the traders will move some pieces around to make it seem like they add value. So what happened is within a very short time window, about 3 to 4 hours, they were actually seeing very spiky surges. And because the entire frickin' street has the meeting at the exact same time, all the banks would use the service at the exact same time before and after this annoying 7:30 meeting. So as you can imagine, if we're spinning up like 100 calcs per second and we're queuing and we can only push through 4 calculations a second, there are some analysts that sit around waiting for 2 minutes for one single portfolio to come up with a value and a projection outwards. So obviously super annoying, and if anybody's dealt with financial services, you know they have no concept of waiting. And also this is expensive. I mean, this was actually a very powerful piece of hardware, and it could only process these many calculations. And they didn't really want to buy more hardware or allocate more hardware because outside of that single window, their service doesn't really get used that much. There's a little bit after the closing market, some stuff gets calculated, but really everyone waits till morning to actually do any real work. Everyone's out partying and drinking. So obviously for various business reasons, they didn't want to buy more servers. So what do? You create this. So this is more like what you guys would probably be dealing with on a day in and day out basis if you're in a larger company. So for that simple app, this is the architecture we're talking about. So once you start to get used to it, it's actually not that complicated, but on first glance, a little bit wonky. So I'm just going to quickly walk you through some of the stuff. So At the bottom, we have the web user channels. So for all the poorer hedge funds that can't really afford custom development for this kind of stuff, they access the website, right? So that accesses the exact same PHP server. We just box it up on a Docker instance to make it easier to deploy and auto-scalable. So in certain circumstances where there are more web users come on board, Elastic Beanstalk will spin up another instance, throw Docker on there, and you're good to go. And with web, if anybody's dealt with website traffic before, it's actually it's quite linear. It ramps up in a nice pace. It actually doesn't ramp up in a crazy ass surge the same way API requests do, which takes us to our top row. So the top row is where all the fun happens. So Barclays and UBS were the biggest offenders, so that's why I like highlighting them. They would hit our API gateway, which if anybody's used AWS, wonderfully scalable, handles all the APIs. We had API keys issued to all the banks. They're all happy with that. They're used to that. And what we did was we actually took the C++ calculation engine, the only thing that actually made any real money for this company, wrapped it in Node.js, and then compiled it for Lambda, right? So because Lambda actually gives you a Docker container, which is the exact copy of a Lambda execution container, you're able to compile literally anything you could ever want, right? So if you wanted to run any sort of genome processing or custom code, and it's written in C, C++, whatever language you want, you can actually take your compiler, take your code, throw it on the Lambda Docker container, build it for Lambda, and deploy the whole thing as one single code slug. So at which point you don't really care that what language AWS runs. Yeah, you can run Python, you can run Java. I don't really give a shit because I can actually compile everything, any language I want, using the Docker container, throw it up on Lambda, and it executes. So now when all the Barclays guys come out from their meeting and they rerun their calculations, they actually use their little Excel plugins that go straight to our API gateway, hits one of the many millions of Lambda units, calculates their portfolios, yada, 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 go make tons of money, right? And we even extended it a little bit more and said, you know what, we'll gut the PHP, connect it to serverless, so there's only one place where the calculation runs, which is in the Lambda function, and you had a beautiful little architecture where it's wonderfully scalable and at the same time wonderfully cheap to run.
So why do you need the Node.js wrapper?
So the Node.js wrapper was just for sanity purposes, actually. You can totally run a regular execution container as long as it just captures the HTTP request. The Node.js one, because we wanted to natively integrate with Lambda's Node.js execution environment, we actually just wrapped it in it. And because Node.js has something that's called native add-ons, that actually allow you to include additional C++ libraries into Node.js and then address them. We're actually able to use that. We added a little wrapper function. We actually were calling DynamoDB, so that complaint about DynamoDB was actually from this client. So there's a little bit of business logic happening in that Node wrapper. And what it also did was it allowed their quants to add new calculation, new libraries. And it was literally, it's about 7 lines of code. They just copy and paste, reference the new algo, and then redeploy. And they have the new algos live. They can call up the Barclays folks and say, you know what, you're ready to go. You want to do some sort of arbitrage? Ready to go. All right? So, in this circumstance, we saw, ironically, about the same benefits, 300%. And that was actually completely unplanned. It was weird and fluky when I saw it as well. But even when we had a server still in the mix that was handling the web requests, the heavy lifting that was really kicking our ass was actually in serverless. So whenever you're looking at existing architectures, try to find the thing that's really kicking your ass. It's really driving a lot of horsepower, driving a lot of requests per second. That piece is usually the first place to start when you move to serverless. You'll see the highest gain. So just moving that one execution and the one calculation engine into serverless, we see almost more than $100 drop per month for this particular environment, right? So now they can go off and sell to the rest of the banks of the world without too much trouble. At most, they maybe need to add 1 or 2 web servers for the poor hedge funds, though I don't really know any really poor hedge funds. and they're good to go. So, for a little proof, this is actually from this morning. This morning's morning meeting. So obviously the time zone is a little bit off, so it shows actually a different time zone. But as you can see, we're seeing about, 102 executions at that window where everyone, that was actually before the morning meeting, and we're perfectly fine. No, absolutely zero thought of invocations. Every single user got their calculation within a second, or less than a second. And we've actually heard zero complaints from any of the banks around this as soon as we moved it to it. The founders of the company came back to us, so they looked at their AWS bill because they have free credits right now, and they're like, we didn't pay anything. Like, why? We were burning at least $200, $300, $400 in the previous months, and as soon as we moved to serverless, we're basically on nothing because they had a long-term contract for that pure server layer, the old T2s, and just like, what the hell did you do? It's like, well, we just moved to serverless. I mean, conceptually, it's a simple concept, but from a financial standpoint, it's amazing. So if anybody wants to play with serverless, that's pretty much your money slide. Is like, you save real dollars, so totally give me a couple of weeks to see if I can get this thing working. And really, any founder, manager, owner really loves these kind of things. So yeah, that's really it. Anybody have questions?